Let's start with F equals ma. This is, of course, Newton's second law of motion, that the force is equal to the mass times the acceleration. So we can rearrange this. Maybe the question is asking you for the acceleration, right? So a force was applied to a certain mass. What was the acceleration of that mass? How quickly did that mass accelerate, or what was its rate of acceleration? So we're going to need to rearrange this. What we want is for the equation to say A equals, the question asks for the acceleration. We want to be able to say, well, the acceleration is equal to whatever it is. Now, there are actually a couple of ways you can go about doing this. I guess the maths way, how maths teachers, in my experience, tend to operate. Let's just go over that one first. Let's start, actually, we won't start with the F equals ma, we'll start with A, B, and C. Let's say we have A plus B equals C, and you want to solve for A. This is how a maths teacher might do it. The maths teacher might say, okay, we've got A plus B. We don't want B there, we just want A by itself. So let's add in a minus B, because those two will cancel. This plus B will cancel out that minus B. So far, so good. However, anything you do to one side of the equation, you have to do to the other side. So if I'm putting in this minus B here, I also need to put in a minus B on the other side. And because the plus and the minus b's cancel out, that leaves me with A equals C minus B, which is, of course, the answer. The same thing for multiplication or division. Let's say we had A divided by B equals C. And again, you're asked to solve for A. Well, we can solve for A by getting rid of the B. We don't want A divided by B, we just want A by itself. So we need to get rid of that divided by B. And how do you get rid of a divided by B? You put in a times by B. So this divided by B will cancel out that times by B and leave us with the A that we want. Great. However, anything we do to one side of the equation, we have to do to the other side. So if I'm going to throw in this times B on the left of the equals, I'm going to also have to throw in a times B on the right of the equals. And then that leaves us with A is equal to C times B, or BC. We tend to write them in alphabetical order, and of course with algebra we can just throw the letters together. We don't have to show the times symbol, the multiplication symbol. So that's really, I guess, how, like I say, in my mind, maths teachers tend to do it. They cancel things out, but then they do the same thing to the other side of the equation. I tend to do it a little bit differently. Let's use the same example as we had A plus B equals C, and we want to solve for A. It gets the same job done. I tend to find this a little bit quicker. Rather than adding the minus B and then cancelling it, and then also adding a minus B to the other side, I just think to myself, I want A by itself. I do not want A plus B. So I'm going to grab that plus B and I'm going to take it to the other side of the equals. And you can do that. You can take things across the equals if you remember that when it's on the other side, you have to do the opposite. So I'm left now with A by itself because I've grabbed that plus B and dumped it on the other side of the equals, but it was a plus B. So when it's on the other side of the equals, it's going to be a minus B. And that's exactly the same answer that we got before. What was our other example? We had A divided by B equals C, and I want to solve for A. Okay, again, I want A by itself. I don't want A divided by B. So I'm going to grab that B and I'm going to dump it on the other side of the equals sign. That leaves me with just A by itself, which is what I'm after. Now, when it was on the left, that B had been divided by, it was A divided by B. So when it's on the other side, it's going to become times B. Instead of divided by B, it will be C multiplied by B, which gives us, again, exactly the same answer. So I like doing it this way. I just dump things across the equals and do the opposite for them. To me, it's a bit easier and quicker. It's just a different method to do it. You can do it the other way if you want. I've got to get rid of that divided by B, so times a B there, and I've got to do the same on this side, and then that will cancel that, and yay, I'm finished. Yeah, I just grab it, dump it across the equals, so long as the opposite is done to it. Okay, so your plus becomes subtracted, your multiplied becomes divided by, etc. So now I'm just going to do it the way I do it. We'll go back to that F equals ma. We wanted to find out the acceleration of this mass. So we have A equals, I don't want A times m. I'm just going to grab that m and dump it across the other side of the equals. It had been multiplied by A, so when it's on the other side of the equals, it's going to be divided by, okay, instead of A times m, we're going to have now F divided by m. So the m had been multiplied, but when it's on the other side of the equals, i.e. with the F, it's now divided by the m. Now, you'll realize it looks like, oh wait, he's switched the sides of his A. But remember, we could have 2 times 3 equals 6, or we could have 6 equals 2 times 3. It really doesn't matter which way we write it. So if I had literally just grabbed the m and dumped it on the other side, I would have been left with f over m equals a. But that's the same as a equals f over m, isn't it? Right? Just like we did up the top here with the numbers. So really we want the subject that we're looking for. In this case, it was the A. We want to really start with that. We want A equals. We don't really want to see all this equation and then see, oh, that equals A, by the way. We want to find A equals this, because that's what the question says. It says, it might have said, what is the acceleration? So I want to say, well, the acceleration is equal to this. And so then I would have the rest of the equation. So I've just sort of flipped the equation, if you like, so that the A is on the left. So I can say A equals this. And then, of course, I would get my numbers for the force and the mass. I would plug them into the equation, reach for my calculator, get my answer, put units on, etc. I've got another video about doing physics calculation problems, but let's just focus on the actual rearranging of the equations, because that is a step in order to do physics calculation problems, and not just physics, chemistry as well, and other stuff. You'd choose an equation, then you would rearrange if you need to, and then you'd do the other steps, put the numbers in, get your calculator, find the answer, put your units on, etc. Show rounding and stuff. But we're just focusing for this one on rearranging the equations. So let's start with another one. Let's talk about some heat, which is Q. Heat energy is equal to the mass times the specific heat capacity times the change of temperature. Now remember, this is like algebra. We don't need to show the multiplication symbols, right? But Q equals M times C times delta T. The symbol delta is a little triangle. It just means change. So if you ever come across that similar little triangle used, it means change. It's a capital delta. It means change there. So anyway, Q equals MC delta T. What might we like to find? I don't know. Let's say we want to find the C. We're looking for the specific heat capacity of this substance. That's fine. So we rearrange to find C. So we want C by itself. We already had a Q on the other side of the equals. I want C by itself. I don't want it times M. So I get rid of the M, I grab it, I dump it on the other side, and it was times M. So over with the Q, it's going to be divided by M. Same thing with the delta T. It was times by C, it was multiplied by C. So when it's on the other side, on the side of the Q, it's going to be divided by delta T. And that's your equation, rearranged. All right, skis. Let's do another. Oh, actually, you know what? Before we do another one, let's just talk about this. If you were now going to solve this, if you put into your calculator, like you had some numbers, maybe the numbers were 3 and 4 and 37, right? It really doesn't matter what the numbers are. But if you put into your calculator now 3 divided by 4. Now remember, this is like algebra, so that M and that delta T have actually been multiplied. So if you then put times 37 equals, get your answer, you're going to be wrong. And then you might not be happy. So just in terms of actually using the equation, I know this is a rearranging equations video, but in terms of actually using it, what you need to remember is that both of those terms on the bottom line have been divided by, it's Q divided by M but it's also Q divided by T. So what you'd actually need to put in is your 3 for your Q, divided by 4 for M, but also divided by 37, not times 37. And when you get your answer, that one you'll get correct, and you'll hopefully be happy with that. Now, if you really want to use that multiplication symbol because you know that, wait, it's algebra, when the letters are written together, they're multiplied, damn it. Well, that's fine. You can use that multiplication symbol if you use brackets, because the M and the delta T are both on the bottom line, but they're both covered by that one line, so they're sort of grouped together. So what you could put into your calculator, if you wanted to do 3 divided by 4 times 37, that's fine, but you would need to do 3 divided by, and then use your brackets because the M and the delta T have been grouped. So divided by 4 times 37 equals, and then you'll get it right and you'll be happy. Okay, so that's just a little aside part on make sure you actually know how to read the equation once you've rearranged it. However, this is a rearranging equations video, so let's move on. Let's do some kinematics now. Let's say we know the final velocity, so v is the final velocity, u is the initial velocity, and we know that one. Plus 2as. A is the acceleration, s is the displacement, and of course 2 is 2. So let's say we wanted to know the displacement of this object. We knew its initial velocity and its final velocity. We knew how fast, well, the rate, I should say, of the acceleration, but we wanted to know its actual displacement. That's fine. We can rearrange this to find s. Now, this equation actually brings in another thing I need to point out. The s is part of this whole thing, right? The 2as. So it's part of that. This u squared is sort of been added on. It's just been tacked on the end. So when we rearrange, now we know that if we take that a across, we're going to divide by a. When we take the 2 across, we're going to divide by the 2. This u squared has been added on, so when we take that across, we're going to subtract the u squared. So we're all good, so long as we consider that if something's been tacked on, either added on or subtracted, we do that one first. So we can't take the a across first or the 2 across first. We have to actually start with this u because it's sort of been tacked on to where the term is that we're looking for. So we have to start with that one. So what we end up with is now v squared minus u squared, okay, because it was added on, so when it's over with the v, it's going to be subtracted. So that's not there anymore. And then we can take the 2 and the a across, and because they've been multiplied by the displacement, on the other side of the equals, they're going to be divided by. All right, so we're going to be divided by 2 divided by a, and we're left with s, the displacement. And remember what I did earlier was I actually just wrote it, started with the s, and then I had the rest of it like this. Just because, this equation and this equation are exactly the same thing. It's just nice to say, well, the displacement is equal to this, and then you go off and work out whatever it is. All right, great. Now, actually, this one brings in the same point as previous, because we have 2 terms on the bottom line. When you reach for your calculator, you would do your v squared, and then you would subtract your u squared, and then you would divide by 2, and then you would divide by a. The 2 and the a are both on the bottom line. We're dividing by both of them. Even though the 2a actually means 2 times a, we are doing the division because they're both on the bottom line. So it's a similar deal to what I just mentioned previously. Okay, let's do another one. Let's talk about the force of gravity. Force of gravity is given by the universal gravitational constant multiplied by the first mass multiplied by the second mass, and that is all divided by the square of the distance between them. Here we go. So this is Newton's law of gravitational force, gravitational attraction. So maybe we don't know the mass of the second object, and that's what we need to find. Okay, well, let's go and find that. M2 equals something. We need to rearrange this equation, so let's do that. I don't want the g there, I want the g on the side with the f, so I take it across, and of course I do the opposite. So it has initially been multiplied, so when it comes across the equals, it's going to be divided by. M1, same. It's going to come across the equals and be divided by. R squared, on the other hand, well, that's been divided by. So when that comes across the equals, we're going to multiply by r squared. And there we go. We could now calculate the mass of the second object. Assuming we knew the mass of the first object, how far the distance between the objects is, and we know the force there and the universal gravitational constant, we can determine M2, the second mass. No problemo. Let's move on. All right, let's move on to a bit of chemistry now. Instead of physics, let's give physics a break. PV equals, not M. So if you write the correct thing, PV equals nRT. This is the ideal gas law when you're working with gases. So we've got pressure times the volume is equal to the number of moles times the gas constant times the temperature. What shall we find? Well, let's find the temperature. Temperature is equal to something. Well, we had a PV on the other side of the equals, and we're going to take our N and our R across and do the opposite, so they're going to be divided by. So you see, I'm sort of getting a bit speedier now. We can just grab something and dump it on the other side of the equals, no problemo. So there we go. We've rearranged to find T. Let's move on and do something else, eh? How about, let's do some more chemistry. This is a fairly straightforward one. The number of moles is given by the mass divided by the relative mass. And maybe we want to work out the mass. So we simply take that MR, the relative mass, and we multiply it by the number of moles. So the mass is equal to number of moles times the relative mass. Okay, it was divided by the relative mass, so when that goes to the other side of the equals, it's now multiplied by the relative mass. All right, skis. Another one. Let's go. What shall we do? How about y equals the square root of 3x plus 17. And we want to solve for x. Right, what are we going to have to do here? Well, we're going to have to get rid of that square root symbol. All right, so if we square everything, all right, that will get rid of it. Great, we can do that. Or we can think of it as taking that square root symbol across the opposite side of the equals. But remember, when we take something across the equals, we do the opposite. Well, the opposite of a square root is to take the square of that thing. So when it's on the opposite side, it's not the square root of y, it's y squared. And it's not on the right-hand side now, so we're left with 3x plus 17. Now remember, we're solving for x, so now we grab the add-on part. We can't take the 3 across yet and divide by 3 because we've got this add-on bit. So we get rid of them first, remember, before we take the parts that are joined to whatever it is we're trying to find. So we take our plus 17 across the other side, it's going to be minus 17, and then we can take our multiplied by 3, take that across the equals and make it divided by 3, and that leaves us with x. So we've rearranged that initial equation to solve for x. Let's do another one or two. Maybe we had x minus p over a. What's the letter D? There we go. That equals D. And again, we want to solve for x. Now, this one has got a little bit of another catch. Sometimes you just need to be aware of these catches, because what I have said is you take the add-on parts and you do them first. So given that, you'd be thinking, okay, well, here's the add-on part, because an add-on part has just been added or subtracted, and I'm going to take that across. And no, you're actually not going to start with that one. In this case, you're going to start with the A. Now, why is that? Well, both the x and the minus p are written above the line, right? So they've both been divided by the a. So they have essentially been grouped. Okay, so we're going to have to get rid of the a first, and then once we've done that, let's do that. X minus p, they've been grouped, and now we get rid of the a by taking it across the equals, doing the opposite, so it becomes a multiplied by d. And now we don't need the groupings, those brackets there. And now we can just say, oh, well, it's x minus p. Get rid of the p. Make it a plus p on the other side, and that leaves us with x. So x equals ad plus p. So that was just a bit of a catch there, in that when you glance at it and you think, oh, I do the minus p first. Actually, in this case, you don't, because it was kind of grouped with the x because they were both on the top of the line above the a. Let's do one more. How about, go away. Thank you. How about we have ax plus b equals c. Well, in this case, that plus b isn't grouped with the x, so in this case we would start with that one first. We would take that plus b across the other side of the equals. We'd be left with ax, how'd that come back? Go away, equals c minus b, and then of course we would do the part that's actually attached to the x, and we'd get rid of that a. There you go, go away. Actually, we can do it cleaner than that. There we go. It's gone away. It was multiplied, so on the other side it's divided by. Okay, so that's how to rearrange an equation. The way I do it is just, if you don't want it there, take it across the equals, dump it on the other side of the equals, make sure you do the opposite. If it was added, it becomes subtracted, and vice versa. If it was multiplied, it becomes divided by, and vice versa. If it was the square root, it becomes the square of, or if it was cubed, it would become the cube root of, etc. So you just do the opposite to what had been done with it. When it's on the other side of the equals, do the opposite. So there you go. Go and practice rearranging some equations. Hopefully this video will help you through that.